Hi guys, in this video, I'm going to show you how to use linear search to find if a number exists in an array or not. So let's try to find number 40. We're going to start at the beginning of the array. So 2 is not 40, this is not 40, that's not 40. Now we found 40. So once we find 40, you can either return true or just return number 3, which is the index or the location of number 40. Let's try to find number 9 in the array. We start here. That's not 9. No, 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 and no. So we didn't find 9 in the array. In this case, you can either return false or return -1, indicating that we did not find number 9 in this array. Let's take a look at the Python code. So we have our function linear search. It's going to take in our array or the list, and we're trying to find the number or the target inside the list. N is the size of the array. We traverse through the array starting from the beginning to the end of the list. If the number that we're at is our target, then we return the index at that location. And after the for loop, we know that it's not inside the array, so we return -1. You can also use this. You can return true and false instead. And you can test the code using these test cases. In the worst and average cases, you have to traverse the entire list and find the element at the end of the list, or you don't find it inside the array at all, but you have to traverse through the entire array, which is n. The best case is when you find the number right at the beginning of the array, so that is all of 1. In the next video, we will discuss binary search, which is faster than linear search. Hi guys! In this video, I'm going to show you how to use binary search to find if a number exists in an array or not. In the previous video, we already discussed linear search, so if you want to check it out, I will include the link down in the description below. Now, the precondition to binary search is that the array must already be sorted from least to greatest. And let's try to find number 40 inside this array. So we put L, or the left, at the beginning of the array, and we put R, or the right, at the end of the array. The second step is to calculate the mid. So the formula for mid is L plus R divided by 2. And L is 0 at index 0, R is 4, and then we get 4 divided by 2, which gives you 2. So the mid is at index 2. We split the array into 2 groups. The first step is to check the number at M. So we're trying to find number 40, and we see that 40 is larger than 30, so it has to be in the second group. We simply move the left over to the second group, meaning that we choose the second group, and we simply repeat the process. So we calculate mid, so L is 3, R is 4, we get 7 divided by 2, which gives us 3.5. And the floor sign means you basically round down, so 3.5 becomes 3. And then we split the array into 2 groups again. We first check the number at mid, and we see that number 40 is here. We successfully found the number using binary search, and you can return true or return the index 3. Let's do one more example and find number 5. So we already have mid, and we split the array into 2 groups. 5 is smaller than 30, so it has to be in the first group. We simply move R over to here, meaning we choose the first group and we repeat the process. So mid is L, which is 0, R is 1, we get 1 divided by 2, which is 0.5, then you round down to 0. And we split the array into 2 groups again. The first thing I'm going to do is check the number at mid. 5 is smaller than 10, so we move R over to this side. Now notice when R is to the left of L, this indicates that number 5 does not exist inside the array. In this case, you can either return false or -1. For practice, I would like you to find number 15 and 50 using binary search. Let's take a look at the Python code. So we put L at index 0 and R at the end of the array. Then as long as L is smaller or equal to R, or as long as L is to the left of R, we calculate the mid index, then we look into the array at mid. If we find a target, then we simply return the mid index. If our number in the array at mid is smaller than the target, it means our target is in the second group, right? So we have to move L to mid +1. And lastly, if it's in the first group, then we move R to mid -1. And after the while loop, we know that R is to the left of L. And that's when we did not find our target and we return -1. Here are the test cases. And this is the recursive function of binary search, but it basically does the same thing. The best case is all of 1 because let's say you calculate the mid and you find the number right away at mid. So you find it immediately and that's all of 1. The average and worst cases are log n, and why is that? That's because every time you iterate through the while loop, you get rid of half of the array. So let's say you have 32 numbers in the array. The next iteration you have only 16, and then 8, and then 4, and then 2, right? So that's basically logarithmic function. And binary search does not create more space, so it is all of 1. Hi guys, in this video, I'm going to show you how to use ternary search to find if a number exists in an array or not. In the previous video, I already explained binary search, so if you want to check it out, I'll link it in the description below. The precondition to ternary search is that the array must already be sorted from least to greatest. Now let's try to find number 10. The first step is to put the left at the beginning of the array and R at the end of the array. We need to calculate 2 mids. So the first mid is L plus R minus L divided by 3. That's just a formula. So L is 0, R is at index 7, and L is at 0 again. So you get 7 divided by 3, which gives you 2.3. And this sign means you round down to 2. So M1 is at index 2. And here is the formula to find the second mid. And R is 7, R is also at 7, and L is at 0. So you get 7 divided by 3 again, and that's 2.3 rounded down, which gives you 2. And then M2 is at index 5. We split the array into 3 groups. And since we're trying to find 10, and 10 is smaller than 30, then 10 must be in the first group. So we simply move R over to the first group, like this. And then we repeat this process. We find M1 and M2, which are at 0 and 1. Here we found 10 at M1. So since we found 10, we can return true or return 0, which is the index of 10. Let's try to find number 45. We look at M1, that's not 45. We look at this, that's 60, which is not 45. But then we notice that 45 is between 30 and 60, so it has to be in the second group. We move L to the second group and R to the second group. And then we repeat this process. So we calculate M1 and M2, which are at 3 and 4. We look at M1 and M2 again, so that's not 45. This is also not 45. But 45 is between 40 and 50. So we move L over here, and then move R over here. Now, when R is to the left of L, this indicates that 45 does not exist inside the array, so you either return false or -1. Let's try to find number 70. We already have M1 and M2, so we look at their contents. So this is not 70, that's not 70, but since 70 is larger than 60, it must be in the third group. So we simply move L to the third group. And we repeat the process. We calculate M1 and M2, and they are at 6 and 7. And there you go, we found 70 at M1 in the array, and we can return true or return 6. Let's take a look at the Python code. So we put L at index 0 and R at the end of the array. And as long as L is less than or equal to R, we calculate the mid1 and mid2 indexes. Then we look into the array content at M1 and M2. If we find our target, we just return the index, which means that we found it. If our target is smaller than the number at M1, then it's in the first group, we have to move R to the first group and we repeat the process. If it's in the third group, we move L to the third group and we repeat the process. But if it's in the second group, then we move L and R to their places accordingly. And after the while loop, R is to the left of L, so we return -1. Here are the test cases. And this is the ternary search recursive function, but it basically does the same thing. The best case is when you find the target at M1 and M2 right away, so it's immediate and it's all of 1. For the worst and average cases, every time you iterate through the loop, you choose one group, right? So you basically get rid of 2/3 of the array. For example, you have an array with 27 numbers. The second iteration, you get 9 and then 3 and then 1, right? So that is log base 3 of n. So that's why the average and worst cases are all of log n. And ternary search does not create extra space, so the space complexity is all of 1. And that's basically it for today. If you guys enjoyed this video, don't forget to subscribe and share. It means a lot.